All right, day 6 is here, and I actually have a sleepover going on outside, so there's a chance I will get interrupted by a couple of 6-year-olds, but hopefully I won't. So, uh, day 6. Let's see if we can bang this one out pretty quickly. Debugger program here is having an issue. It is trying to repair a memory reallocation routine, but it keeps getting stuck in an infinite loop. In this area, there are 16 memory banks. Each memory bank can hold any number of blocks. The goal of the reallocation routine is to balance the blocks between the memory banks. The reallocation routine operates in cycles. In each cycle, it finds the memory bank with the most blocks, ties one by the lowest numbered memory bank, and redistributes those blocks among the banks. To do this, it removes all of the blocks from the selected bank, then moves to the next by index memory bank and insert one of the blocks. It continues doing this until it runs out of blocks. If it reaches the last memory bank, it wraps around until the first one. I would like to know how many redistributions can be done before a blocks in banks configuration is produced that has been seen before. For example, imagine a scenario with only 4 memory banks. The banks start with 0, 2, 7, and 0 blocks. The third bank has the most blocks, so it is chosen for redistribution. Starting with the next bank, the fourth bank, and then continuing the first bank, second, and so on. The 7 blocks are spread out over the memory banks. The fourth, first, and second banks get 2 blocks each, and the third bank gets 1 back. The final result looks like this: 2, 4, 1, 2. Next, the second bank is chosen because it contains the most blocks. Because there are 4 memory banks, each gets 1 block. The result is this. Now there's a tie, both which has 3 blocks. The first bank wins the tie, and its 3 blocks are distributed evenly over the other 3 banks, leaving it with none. The fourth bank is chosen, and its 4 blocks are distributed such that each of the 4 banks receives 1. The third bank is chosen, and the same thing happens. At this point, we've reached a state we've seen before. 2, 4, 1, 2 was already seen. The infinite loop is detected after the 5th block redistribution cycle. So the answer to this example is 5. Given the initial block counts in your puzzle input, how many redistribution cycles must be completed before a configuration is produced that has been seen before? Okay, this sounds slightly, doesn't sound hard, but it sounds slightly complicated. Redistribution.py, and let's, what I would like to do is I would like to write this, as always, I'll add this URL as my doc string. And from typing import list, because I know I'm going to want to do that just based on reading the problem. And so I want to write this redistribute, and what do I want to call this? In this area, there are 16 memory banks. And we know there are 16 memory banks, I guess, so there's definitely 16. I don't know why they wrote it out like this. But anyway, memory, and memory is a list of int, and this will return, we're just going to mutate it in place. So we take some memory and we mutate it. And we know that memory has 16, but I'm not going to count on that because it's not really that important. And so what do I want to do? In each cycle, it finds the memory bank with the most blocks, ties one by the lowest memory bank. Let's find take from index. And what we want to do is basically say max blocks equals max of memory. So find the largest number of blocks, and then we want to say take from is going to be the smallest I for I value in enumerate memory if value equals max blocks. So in other words, you say, you know what, the biggest one is 4, and we just want to take the the smallest one. And because we're going in order, we could actually just take the first one, but I'll just leave it this way. So we want to take from there, and let's say num to redistribute equals memory take from, and these are not going to be great variable names, but whatever. And then we'll say memory take from equals 0. And then if I understand it correctly, what I do is I just, let's just say index equals take from plus 1. And they said it's going to be 16, but let me just do num, what do we call this? Num banks. There's no real reason to hardcode 16, and maybe next problem they're going to ask us to change it or something, because they do stuff like that. So let's just get a number of banks is the length of the memory. So we we take this largest number, and that's how many. Actually, num to redistribute is just max blocks, right? Because, so I don't need to look it up again. And memory take from equals 0. And so now I want to start redistributing in the next one. So for in range num to redistribute. So I want to redistribute those. And so that many times I just want to do memory index plus equals 1, and then index equals index plus 1 mod numbank. So it'll wrap around, right? And I think that's what we've described. And plus, by not hardcoding 16, that will allow us to run this test case. So let's do an IPython, and we can run day is it 06? Day 05? I feel like it's day 06. It is day 06. I named it wrong. So let's rename this to day 06 redistribution. Let's run that, and then we start with 0270. So let's just check that out. Memory equals 0270. Redistribute memory, and then it's 2412. That's good. Redistribute memory 3123, and then redistribute memory 0234, and then redistribute memory 1341, and then redistribute memory 2412. And so what we've done is we've called redistribute 1, 2, 3, 4, 5 times, and we've seen something we've seen before. So that's good. And so we want to find how many cycles must be completed before a configuration has done that has been seen before. So let's say how many cycles, memory and list int, and this will return an int. So as I did, in the last one, I'm just going to make a copy of it so that I don't destroy whatever I pass in. So if we do like a test case or whatever, and then I'm going to do seen. So we have to track what we've seen, right? And we do some kind of set, but I can't do a set of lists because lists are not hashable. So I'm not going to give it a. This is bad. I'm not going to give it a type hint, okay? Anyway, actually, you know what? I'm not going to give it a type hint. And it'll complain with me, but getting the type on this right is actually going to be tricky, so I'm not going to worry about that. So what I want to do, and again, I will use import itertools because itertools is fun. For cycle in itertools.count from 1, and let's make sure we don't have an off by 1 error. We'll figure that out in a second. So scene is actually going to be, and I'll call it tuple of memory. So our set is going to store tuples of numbers because you can't put lists in a set, like I said. So what I want to do is say memory equals, or it's not even memory, it's just want to redistribute memory. And then as tuple equals tuple memory, if as tuple in scene, return the cycle. Otherwise, and it's probably plain because I'm doing return again. Otherwise, scene dot add as tuple. Okay, so I think that makes sense. And let me run this again now. How many cycles, and what was that input I had? It was 0270, 270, and that says 5 cycles. So that looks pretty good. So now let's get our puzzle input. Right, I already got that. So if name is main, so input is this terrible string, and then let's say memory equals int x for x in input.split. I think that should be good. And then print how many cycles memory. So now let's run this and see. 1,208 for 1. Should I add a print statement? Sure, why not? Print memory. So let's see what happens. So that's a lot of redistribution. And let's just sanity check one of these. So here's a 14. That 14 gets distributed everywhere else, so that seems pretty reasonable. Let's try and find one if we can where there's a tie and look at that. There's a lot of 14s here. 15. 15. So here's one with 2 14s and it redistributes the first one, so that's good. Here's one with 2 actually, no, this one has a 14, so it redistributes it. This one has 2 14, so it redistributes that one. Okay, so seems pretty reasonable. So let's try this, and 12841. So let's try it. That's the right answer. Good. 1 gold star closer to debugging the printer. So let's look at part 2. Out of curiosity, the debugger would also like to know the size of the loop. Starting from a state that has already been seen, how many block redistribution cycles must be performed before that state is seen again? The example above, 2412, is seen again after 4 cycles, and so the answer in that example would be 4. How many cycles are in the infinite loop that arises from the configuration in your puzzle input? Okay, so that's not a hard change. How do they, the size of the loop? So, just so that we have a record of what we did, I'll make a new function that's doing mostly the same thing. Size of loop. So now what I'm going to do is I'm going to do first scene, which is going to do, instead of being a set of just the states, it's going to be a mapping from the states to when I first saw them. So, I'm going to say I first saw this guy, the initial memory, at time 0. And now what I'm going to do is for cycle in iter tools count 1, I'm going to reuse through the memory, do it as tuple. If as tuple in first scene, return cycle minus first scene as tuple. So, if we go to the second index 1 and we see the same guy again, it's going to subtract off when he was first seen. Otherwise, what I will do is I'll say first seen as tuple equals cycle. The cycle is a bad, no, I guess it's fine. So now if I do this, I can do print size of loop memory, and see, this is where it's good that I did this defensive copying thing here, because otherwise, once I did this first time through, it would have destroyed that variable. But here, because I made a copy, it should be fine. So this says that the first loop is 8038. So let's just try doing that. That's the right answer. 1 gold star closer to debugging the printer. So that's the end of day 6, advent of code. Here's this pretty thing, and day 7 is not going to happen for another 23 hours. So I guess I won't do it for another 23 hours, but get status, get add day 06 redistribution, get commit.m day 6, get push, and all these files are up on GitHub. So that's it. This one we were able to do without too much of a problem again. So maybe, day 3 was this terrible anomaly, and thank you for watching, and I'll see you next time.